Hello students, how are you? Hope you all are in safe and cautious and in home. You know everyone, right now we are passing through a very challenging situation for the coronavirus that we are known as the COVID-19. And as a teacher, I request you everyone, don't be get panicked, don't be get anxious, be cautious, be safe, be steady in your life and always present in your home and must be sincere on your study. Okay, follow the government instructions, clean your hands repeatedly with soaps or hand sanitizer. Okay, and definitely hope we will win over the COVID-19. Thank you. So in last day we will study up to the reactions of the Grignard reagent with CO2 under the preparation of the carboxylic acid. Today we will start from the carboxylations of alkene under the preparation of the carboxylic acid. And before starting your class, I want to say that this video is very important video. So I request you everyone careful, attentive on my lecture up to the last of my video. Okay, thank you. So today first is the carboxylations of alkene. It is one of the most important reaction because this reaction is used in industry for the preparation of the carboxylic acid. This reaction is also known as the Koch reaction. If your question come in examination, what is the Koch reaction? You will write this one. Okay, the carboxylations of the alkene. So what will happen in the Koch reaction? In the Koch reaction, an alkenes will react with carbon monoxide and steam it at 400 degrees Celsius temperature under pressure with phosphoric acid. Okay, and ultimately a carboxylic acid will produce. This is the Koch reaction. Here I have given the example by the ethylene. Hope you all can see it. Here ethylene reacts with the carbon monoxide and steam it in presence of the phosphoric acid at 400 degrees Celsius temperature, and propionic acid is the end product. Okay, it is the Koch reaction. Next one, it is the last one of the carboxylic acid synthesis, that is the malonic ester synthesis. What will happen in the malonic ester synthesis? Here an alkyl halide reacts with the sodium derivative of the diethyl malonate and produce the substituted malonic ester. Okay, and this substituted malonic ester will be hydrolyzed or decarboxylated, ultimately produce the carboxylic acid. Okay, it is total reactions of the malonic ester synthesis. See, here I have given an example for the methyl bromide. Okay, here methyl bromide will react with the sodium diethyl malonate. Clear? And when these two products are the react, here has been produced one substitute product, that is the sodium derivative of the diethyl malonate. Clear? And this product will be hydrolyzed to form a product, and which will be totally decarboxylated to produce the ultimate end product is the propionic acid. Okay, it is the overall malonic ester synthesis. It is the overall malonic ester synthesis. You can take a screenshot of this page. Okay, thank you. So it is the overall carboxylic acid preparation. Now we will start the physical property of the carboxylic acid. It is very simple. First 10 carboxylic acids, molecular weight is lower and they are the liquid in nature. Okay, first 10 carboxylic acids are lower molecular weight and they are liquid in nature and containing disagreeable odor. Okay, and the higher molecular weight carboxylic acids, they are the wax like solid and they are containing almost odorless. Okay, that means they containing the no odor, almost odorless. Next one, first 4 carboxylic acids readily soluble in the water. Why? Because they are forming hydrogen bonds with the water molecule. Okay, so they are readily soluble in the water, and the remaining carboxylic acid, they are readily soluble in organic solvents like defined organic solvents like the ether, like the benzene, etc. Next, the melting points of the carboxylic acids are increasing with the molecular weight. Okay, when the molecular weight is increased, their boiling point and melting point both are regularly increased. And one more important thing, suppose a carboxylic acid and an alcohol, both are containing the same molecular weight. Suppose in example, acetic acid and 1 propanol, both molecular weight are 60, but in this case the boiling point of the carboxylic acid will be higher than the alcohol. Okay, it is one more important thing. If 1 carboxylic acid and 1 alcohol containing the same molecular weight, then in that case the boiling point of the carboxylic acid will be higher. Clear? See, suppose in case of the acetic acid and 1 propanol, both molecular weight are 60 degrees Celsius, but the boiling point of the acetic acid will be more or less 118 degree to 120 degree approx, and 1 propanol boiling point more or less 100 degree Celsius. Okay. Next, it is most important thing of the carboxylic acid chapter, that is the acidity of the carboxylic acid. So first thing, what is acid? Hopefully you know everyone, you have studied it from the 7, 8, 9, 10, 11, 12. Okay. So what is the carboxylic acid? Sorry, what is acid? Acid is such substance which gives proton, that means H plus ion, in its aqueous solution. And another property of an acid is what? It will react to the base and produces salt and water. Okay. Same thing in case of the carboxylic acid will happen. When carboxylic acid ionizes in aqueous solution, it produces the H plus ion, and when carboxylic acid reacts with a base, it will produce a salt and water. Okay. See, carboxylic acid, here I have given the example here 1. Okay. Carboxylic acid reacts with the base sodium hydroxide and produces salt and water. Clear? Next one, that is the very important thing. What is acidity constant? Before describing the acidity constant, I want to remember you another thing. Hope you know everyone the conception of the strong acid and weak acid. What is the strong acid? Strong acid means in aqueous solutions which totally dissolves and produces H plus ion. And what are the weak acids? Weak acids are those acids which in aqueous solutions only partially dissolves and produces H plus ion. Okay. So carboxylic acid falls under the second group. It is a weak acid. In aqueous solution, it is partially dissolved and produces the proton or H plus ion. So there are an equilibrium condition will arise between the ionized form and unionized form. Okay, there are an equilibrium condition has been happened between the ionized form and unionized form. The important thing is, see, there are lots of carboxylic acids and the acidity of all carboxylic acids are not same. So how we will describe which carboxylic acids bears the more acidity and which carboxylic acids bear the less acidity? We will describe it by the conceptions of the acidity constant. What is the acidity constant? The conceptions of the acidity constant we will describe from this equilibrium condition. Okay. What is the definition of the acidity constant? And we will mark the acidity constant as the Ka. Okay. I will see you later. So what is the acidity constant K? See, the K acidity constant is described as the concentration of the ionized product. Okay, when the carboxylic acid is partially ionized, okay, there are one ionized part of the solution and one unionized part of the solution. Okay, so the acidity constant of the K will define by the concentration of the ionized products in moles per liter. Okay, in moles per liter, the concentration of the ionized part of the product that will divide by the unionized part of the acid. Okay, the total concentration in moles per liter of the ionized part will divide by the unionized part of the acid. That will derived as the acidity constant Ka. Okay, it is the Ka. See here the total ionized part. Okay, first one is the ionized part of the acid and second one is the ionized part of the water. Okay, see, in the solution there are the two products are present. One is acid and another is the water. So first is the ionized part of the acid and second one is the ionized part of the water, divided by the unionized part of the acid. That is defined as the Ka. This conception is very much important for the describe for the acidity of the carboxylic acid. Okay, which carboxylic acid contains the stronger acid, or which carboxylic acid not stronger acid. Stronger acid means the acidity is much more higher than the other carboxylic acid. Okay, I will describe it on later. Okay, and hopefully at that time you can understand it. Next one, explanation of the acidity. How we will explain about the acidity of the carboxylic acid. See, carboxylic acid is acidic because previously I have also told, like all the general acid, it will lose a proton, and after losing the proton, what will happen? It forming the carboxylate ion through either ionization in aqueous solution or reaction with a base, and ultimately this carboxylate ion is stabilized by the resonance. Okay, see here. Okay, I have given here the example of the carboxylic acid. See here, first one, here the double bond is transferred here, and due to that reason, in the next step it contains the negative ion of the oxygen, and here the previously oxygen ion contains the negative and it is converted to here. So it is the resonance form. It is the resonance form of the carboxylate ion. Okay, and ultimately they got stabilized by forming the resonance hybrid. Okay, you can take a screenshot of this page. It is also very important. Thank you very much. Next, what is the effect of the substituent on acidity? See, here one important term will come here, that is the inducing effect of the substituent. The inducing effect will happen on the alpha carbon atom. In last video I have described about the alpha carbon atom, beta carbon atom in case of the carboxylic acid in the common nomenclature. So in the alpha carbon atom, the substituent producing the inducing effect. Okay, and that will be decide the either increasing the acidity by the substituent or decreasing the acidity by the substituent. Okay, there are the two kinds substituent is be happen for the increasing or the decreasing of the carboxylic acid. Suppose if any alkyl group is attached to the carboxylic acid alpha carbon atom, then the acidity will be decreased. the acidity of the such carboxylic acid will be decreased. But if any electron withdrawing group is attached to the alpha carbon atom of the carboxylic acid, then the acidity of that particular carboxylic acid will be increased. How? Because in case of the alkyl group, you know everyone, the alkyl groups are the electron releasing group. Okay, and due to that reason, they increase the negative charge. They increase the negative charge of the carboxylate ion, and due to that reason, the release of the proton will be difficult. And if the proton release will be difficult, hope you can understand everyone, the acidity will also be decreased. And another point is there, the size of the alkyl group is also increased, and that will also responsible for the decreasing of the acidity. Okay, so if any electron releasing group is attached to the alpha carbon atom, then the acidity of the carboxylic acid will be decreased. Clear? See, here I have given the two examples. Okay, see, in first case of the formic acid, here the no alkyl group is present and its K containing, that means its acidity is the 17.7 into 10 to the power minus 5. And if in alpha position of the carbon atom one alkyl group, okay, if any alkyl group, that is the CH2 group is attached here, okay, in alpha position, it produces the acetic acid, and the acidity here decreases from the 17.7 into 10 to the power 5 to 1.76 into 10 to the power 5. Okay, so for the attaching an alkyl group, the acidity will be fall. Okay, you can take a screenshot of this page. Thank you everyone. Next one, if an electron withdrawing group is attached to the alpha position of the carbon atom, the opposite thing has been happened. That means it decreases the negative charge of the carboxylate ion. Okay, and if decreases the negative charge of the carboxylate ion, what thing will be happen? The carboxylate ion will be stabilized and releasing of the proton will be easy, and the acidity will also be increased. Okay, what are the electron releasing group? Those are the electronegative, that means the negative ion containing, that means the chlorine, bromine, cyanide group, etc. See, here I have given the example. See, second one, first you will notice that in case of the acetic acid, like the previous one, okay, in case of the acetic acid, the value of the K, that means the acidity is the 1.76 into 10 to the power minus 5. When in this alpha position one chlorine group is attached, it is converted to the chloroacetic acid, and the value of the K, that means the acidity will increase from 1.76 into 10 to the power minus 5 to 136 into 10 to the power minus 5. Okay, more or less 10 times, 10 to 15 times. Okay, so hope you can understand, when an electron withdrawing substituent attached to the alpha position of the carbon, it will increase the acidity. Okay, you can take the screenshot of the page. Thank you everyone. So today's lesson is over on here. If you have any doubt, you can feel free to contact me on my WhatsApp number in our WhatsApp group. Okay, and in our next video we will start the chemical property of the carboxylic acid. Okay, be cautious, be safe, stay home. Thank you everyone.